Hey, good morning, class. Mr. Bean here. I've been asked to do a special request to help maybe give a video presentation on how to do some of the simulations found on Lab 3 for summer assignments, Unit 1 for AP Physics. So let's go ahead and just get right to it. So we have 10 simulations that we want to be able to do, and we want to be able to put the correct solution or certificate in the yellow box. So let's go and take a look at this one here. It's called Learning to Curve Fit. So we'll go ahead and click on the link here. And here's what we got going on. All right. So it says data generator for learning to graph. So here's a graphing program. Now we'll use this a lot in class. Let's go ahead and click on it. And this opens up right here. So let me go ahead and let's minimize this here. And let me kind of go like this. And let's split screen this. And I'm going to go ahead and put this curve generator over here, or this basically is a graphing tool. Okay, and let's go ahead and go back to here again. And so this is called Quick Graph 5. So whenever I ask you to use a graphing tool, we use Quick Graph. We'll use this tool. Sometimes we'll use the Google spreadsheet, and sometimes we'll do it by hand. But anyways, we'll click on it here, and it says here, data generator for learning to graph. It says stretch of a spring that has been given various amounts of energy. Okay, and so here is presented so this would be the x, and this is the y. Okay, so here it says stretch of a spring that's been given various amounts of energy. So we got to be careful about this here. Okay, so which one of these? So what is this asking? So it's asking is how much will the string stretch based on energy? Okay, so in this example here, the x, whatever's in the x column is usually what we call the independent variable. The y column is usually what we reserve for the dependent variables. In other words, the stretch depends on energy. Okay, uh, or given various amounts of energy. Yeah, so the stretch of a spring given various amounts of energy. So that tells me that or actually, hold on, my bad. Stretch of a spring given various amounts of energy. So we're going to give energy. What's the string stretch? So my bad. This will be the x-axis. This will be the y. So this is the independent variable energy, and the stretch is a dependent variable. All right, so we'll go over here, and now you can fill this out. I'll go ahead and go right here, and I'll go ahead and put in there, we'll call it stretch. Okay, and it is in centimeters. Okay, and the dependent variable, oh, hold on, my bad, hold on. The energy in joules is the independent variable, and the stretch in centimeters is the independent variable. So given energy, how much stretch will we get? So essentially what we'll do is we'll just do the first couple with 0 here, 0. Now look at energy. We have 41 joules, 34. Notice it's not in order. 17. And so 41 corresponds to 84.79. 34 corresponds to 78.96, and 17 corresponds to 55.09. So I would just keep on going. Now notice it's not in order, but it's actually not necessary per se. Well, maybe we'll do a couple more. Here's energy. Well, let's go ahead and do them all. 17, so there's 7. There's 7 here. Go with 42. Let me go ahead and pause the video, and I'm going to go ahead and put in all of the numbers. All right, so we have all the data in here. And so now what we want to do now is take a look at our graph. Okay, so we have stretch versus energy here. Okay, and let's see. Okay, so stretch versus energy. Notice when we do this here, whatever was in the y-axis always goes first before the verses, and whatever is in the x-axis always goes here. Okay, we will use that concept throughout the entire course. All right, take a look here, and now we want to do is curve fit. Okay, is it proportional? Proportional and linear look the same, but proportional means the origin y equals mx plus b. It goes through the origin. That's proportional. If it's linear, it means it doesn't necessarily have to go through the origin because it could have a y-intercept. So looking at this here, it doesn't look like it's proportional. It kind of looks like a curve here. Okay, so here's squared. It doesn't look like it's squared. Here's cubed. Here's square root. This looks like a possibility. This means no relationship. Okay, this is inverse, inverse square root, and exponential. So unless you're very sure in this class, I would just go with nonlinear. So this graph appears to be nonlinear, and I think it's going to be square root. See how it kind of fits here? And here's the relationship here. So what we would do here is I would go ahead and I would go ahead and screenshot this. We'll go here and let me go ahead and new. We go ahead and just go like this here. Okay, I would hit copy like so, and I would go back to the actual lab sheet and I would go ahead and just paste it into here. Paste it into here. Okay. All right. So that's number one. Okay. So simulation 2 is called finding equation of linear graph. Let's go and take a look at that. Okay. All right. So go ahead and begin. All right. So what we're looking for here is y equals mx plus b. Okay, so so normally what we do is here's a line here, and looks like it could end up going to y-intercept something over here, but I'm not sure yet, so I have to figure out 2 points. So the key here is try to find 2 points where the line goes to like an exact coordinate. So I'm thinking like right here is one spot. Let me make it a little bit bigger so we can maybe kind of see this. There we go. And let me go back to the pin again. And where's another spot? We may have to guess a little. Yeah, maybe right here. Okay, it looks like these are 2 points here, right? And remember now to find the slope, right? Slope is equal to, right? Was it y2 minus y1 divided by x2 minus x1. Okay, so there's the slope. Okay, once you have this, we would plug it into right here. Okay, now we got to find the y-intercept. Okay, to find the y-intercept. Okay, so we're still going to use y is equal to mx plus b, right? So I'm going to choose the y, choose any, here's 2 points, choose either point, put the y coordinate in there, put the x coordinate, and put in the slope that you just found. Now we can solve for b, and that's what we want to do. So once we do that, I would click end, I put my name, the slope, and the y-intercept, and we hit submit, and we're good to go. All right. Okay, let me go ahead and erase this, and we'll look at the next one. Okay, simulation 3. Take a look at simulation 3 here. Is graphing motion level 1. Okay, let's go and take a look at this and see what we got. Okay, so click on this here. Now we'll hit begin. Okay, and here it says, go ahead and read this here, and we want to find the velocity. Okay, find the velocity, either positive, negative, or 0. Okay, we'll hit begin. All right, now there are 3 distinct regions here. Okay, we'll call this here region 1. This will be region 2 here, and this will be region 3. Okay, all right, so we have position versus time. So velocity is simply going to be the slope. Velocity is the slope. Okay, so since we have a horizontal line here, we know the slope here is 0. Therefore, velocity is 0 in region 1. Now look at region 2. This is a positive slope. So the velocity here is going to be positive. So we have to find 2 points and find the slope of this line. Over here, this is a negative slope. So the velocity here is going to be negative. So find any 2 points and just simply find the slope. And once we do that, we go back over to here. I hit end and I plug in my name, the velocities in the various regions here. Okay, let me go ahead and hit pause and we'll start again. All right, take a look at simulation 4. Okay, let's go ahead and click on that. Let me get the mouse here. So here is simulation 4. Take a look at this one here. Okay, so here we hit begin here and go ahead and read this and we'll see what we got going on. So we want to find what's called instantaneous velocity at a particular time. So this object, its speed is changing. Okay, its speed is changing. So I want to find the velocity at time equals 6.1 seconds. So here's the current yellow dot here. And so I got to use the tangent line. I got to move it until I get to 6.1 seconds. So I'm moving it, moving it, moving it, and so there's 6.1 seconds. Now, if I was in a calculus class, I'd be finding the derivative at t equals 6.1 seconds. So the slope of the tangent line at 6.1 seconds is the instantaneous velocity. So this is like your speedometer telling you your exact velocity at a particular moment in time. So at 6.1 seconds, I need to find the slope of this tangent line, and that will be the velocity at 6.1 seconds. Okay, let me hit pause. Okay, all right, so let's go ahead and let's go to number 5 here, finding instantaneous velocity at 2 times and then finding the average acceleration. All right, so let's go here. All right, so let me go ahead and hit begin. Okay, so it says find the velocity at 0.2 seconds. Okay, so let's go ahead and do that first. Okay, so I'm going to go ahead and find so at 0.2 seconds, so I have to kind of move it way over here. So I'm going to go ahead and go over here. We need 0.2 seconds. So let's take a quick look here. There's, okay, so that's 0.1. There's 0.2. So 0.1, so there's 0.1, 0.2. Yeah. So what we do then is that I find the velocity at 0.2 seconds in this particular example. Okay. So that's the instantaneous velocity at this location. Okay. Now it says at 5.6 seconds. So I go over here, I move it until I hit 5.6 seconds. Okay. And let's go over here. So there's 5, 5.1, 5.2. Okay. So, excuse me, 5.6. There's 5.5, there's 5.6. All right. So then I find the velocity at 5.6 seconds. Okay. So that means I got to find the slope of this line when the tangent line meets right here. Okay. So that's going to be 5.6 seconds. Okay. Then it says, what's the average velocity between these 2 points? So velocity average is just basically going to be the velocity at 2 seconds plus the velocity at 5.6 seconds, and I'm just going to divide it by 2. So that would be the average. Okay. Okay. So let me go back here. I would hit end, and I would find the velocity here, here, and the acceleration. Okay. Which, let's see. Oh, no, hold. Back. My bad. If it wants acceleration, hold on. Okay. Let's see. So the acceleration is going to be the final velocity. So whatever the velocity is at 5.6 seconds, subtract the velocity at 0.2 seconds, and whatever the time is between those two. So the time would be 5.6 seconds minus 0.2 seconds. Okay. So I would do that, and that would be my acceleration. Okay. Hit submit. Hit pause. All right. So now we go over here. Number 6 is distance and displacement challenge. Okay. We'll go over here and okay, so this challenge, you'll be in control of an object. You must, for your object, match a randomly generated distance and displacement. You'll only be given to move right and move left command. And so I'm going to plan your route ahead. And when you're ready to start, click begin. we'll go here. All right, so it says your challenge is to move the object a distance of 8.9 meters with a displacement of 1.2 meters. Okay, now let's make sure we understand what's going on here. Okay, so the total distance traveled must be 8.9 meters. Okay, that's distance. Okay, now displacement. Okay, delta x is displacement. Okay, hold. Let me put in here. Let's do delta x. Okay, hold on. Uh, delta x, and this is a vector. Okay, displacement. Displacement has to be 1.2 meters. Okay, now. So what this means is that when we do this, it's going to be the final x position minus the original starting position. Okay, that's delta x. Okay, so let's make sure we understand this. So there's delta x here. So what is my starting position? Starting position is here's 0. This is 0.1, 0.2, 0.3. So we'll say our starting position is 0.3, right? And here is my final position here. Okay. Now, what's the displacement have to be? It has to be 1.2 meters. Okay. So here's 1.2 meters. So to find my final position, here's my final position here, right? Okay. 1.2 minus 0.3, is it 0.9? 0.9. So it has to be, I have to be 0.9 away from here. So I can be 0.9 this way, or I could be 0.9 that way. Now, this is positive, right? So I'm thinking over here. Now, I have 8.9 meters I have to move. Okay, so that means this has to move 8.9 meters, and I have to come back to be able to. So where's my final resting spot? It's 1.2 meters. So here's where I need to end up. I need to end up here. Okay, so I need to either move this way and come back and end up here, or move this way and come back. Whichever way I go, I have to travel 8.9 meters and end up here at 1.2 meters. Okay, that's how I do the situation. All right. All right. So next up we have is a graphing skills challenge. Okay. All right. So we're here. Okay. So let's go ahead and put in our name. I'm gonna go ahead and use Thanos as our name here. We hit begin. Okay. And so basically just read through this and you just go ahead and figure out what's the x-axis, what's the y-axis, and just a step-by-step tutorial to help you with your graphing skills. Okay. All right. So here we have finding displacement from a velocity versus time graph. So let's go ahead and take a look at that. All right. So go ahead and click on begin here. And here we have velocity versus time. Okay, so now this area here under the curve will give us displacement. Okay, now how I would approach this is that I would make rectangles. Okay, because remember a rectangle, the area of a rectangle is 1/2, right? Base times the height, right? And a rectangle, this may be width, this is length. Area would be length times width, right? Okay, so I would find it. So this to me looks like it's an area. I would find this area here, which we'll call number 1. I would find this area right here, which we'll call number 2. And I would find this area here, which is number 3. So these are area under the curve. I would find this area, this, and add them all together. Once I add them together here, I would go ahead and put my displacement here. Okay, and that's so area under the curve is displacement. Okay. Okay, so next up is finding displacement from velocity of a graph, time graph part 2. Okay, so let's click on this and see what we got. Okay, all right, so here now, we'll click on begin. Okay, a little bit trickier. Okay, now a couple things of interest to keep in mind here. Okay, this is 0. These are negative down here, right? Okay, you gotta be careful. These are negative. All right, so we're going to find the area either under or above the curve associated in relationship to the zero axis, or to the zero, to the to the zero axis here. Okay. All right. So what I would do is I would find, for example, I would find this area right here. We'll call this area 1. Okay. All right. This looks like length times width. Okay. Now this right here is a triangle. Notice it's above the x-axis. So I would find the area of this little part right here, which is 1/2 base times the height. Okay. Now this part here is a big triangle. Notice the triangle here is below the 0. Okay, it's negative. So I would find it. Now this looks like a triangle here. So I would do 1/2 base times the height. Now the height is going to be negative. It's going to have a negative value. Therefore, this area here will be negative. Okay, so this will be area 2. This will be area 3. Okay, we go over here. This looks like a triangle, positive. Okay, I'll call it area 4. It'll be 1/2 base times the height. So I would add up all of these areas to find the displacement. Okay, now just keep in mind when this is a negative, that means that the object kind of like, let's say I started from here. Okay, and this part here tells me I went like this. Then the negative area means I came backwards. Then I went like that. So how far did I? What's my displacement from starting point to my ending point? Okay. All right. We'll hit pause. Okay. All right. And then finally here, external timing challenge. We'll go here, and we'll put in here Thanos again, okay? Or actually Loki. I like Loki. Okay. Really big in the Marvel and Star Wars. So a lot of Marvel Universe references in class. Hit begin. Okay. So use an external stopwatch. The car travels the first 100 meters. Okay. So don't start timing until the car reaches the mark 0. Okay. Click on the car and give you a chance to get ready. We'll click on the car here. Click on the timer. Okay. Ooh. Let's see. Where is the timer at? Hold on. Let's restart this again. Okay. All right. Your job is to challenge to determine the time it takes to travel 100 meters. In this activity to demonstrate your teacher. Okay. You use a stopwatch. I would use your iPhone. Okay. That's what I forgot. Okay. So we put in here Loki again. Okay. So we hit begin. Okay. Now I have my iPhone out, or my Android, or any other timing device. Okay. So we click on the car here, and then once it gets ready, so when it reaches here, I have my iPhone, and I would start the timer. Okay. And I would watch it, and then when it stops at the 100 meter mark, I would stop the timer. Okay. We're here, looking ready here. So we'll use the front of the car. So when the front of the car reaches right here, stop. Okay. And then we'll go ahead and put the time in. Okay. And that's it. Okay. If there are any other questions, make sure you contact me and we'll go from there. All right. See you guys in class on Monday.